My name is Marico and I'm a PhD student at University of Toronto in the Civil Engineering Department, and I'm in the Sustainable Infrastructure group under Professor Chris Kennedy. So my area of interest is in sustainable and resilient neighborhood design. In the past, a lot of focus has been on sustainability. How do we live greener and how do we prevent climate change? But now that climate change is occurring, or seems to be occurring, the focus has shifted a bit to climate change adaptation and how we can be resilient to the future changes. So I'm looking at neighborhoods and how we can design neighborhoods to be not only sustainable but also resilient to climate change impacts and other future impacts. In terms of modeling, a lot of modeling has been done at the building scale, but not as much has been done on the neighborhood scale. So I'm going to be creating a model at the neighborhood scale of buildings, and I'm going to use Toronto as a location, and I'll be using future weather data instead of current weather data. My first step was to look at what the future would be like, and climate change is a big part of that. So I focused a lot on climate change. And then the second step of my research is to ask the question, what does this mean for a neighborhood, like a neighborhood in Toronto? How would we design a new neighborhood in Toronto to be appropriate for the future? There's been some work in looking at the relationship between sustainability and resilience. For instance, there's some strategies that are sustainable but not resilient. For instance, solar PVs that people have on their houses that are connected to grids. They're sustainable in the sense that they reduce greenhouse gases because they use solar energy. But when a crisis occurs and the power goes out in an area of the city, if you live in that part of the city and you have solar PV, if the power goes out, your solar PV will also go out for safety reasons. So in that sense, the solar PV is not resilient in that during a crisis, it can't help you. And there are also some strategies that are resilient but not sustainable. For instance, some people might have diesel backup generators so that when the power goes out, they can fire up their diesel generator. So that's resilient in that you have power during an outage, but it's not sustainable because it releases greenhouse gases. So trees are a great example of something that is both sustainable and resilient. They're sustainable in that they reduce greenhouse gas emissions and provide oxygen, and they're resilient in that they absorb water and reduce stormwater runoff, and as well they provide shade, which is extremely useful when we have extreme heat. As a PhD student, I had the opportunity to teach a class in civil engineering. It was a second-year class called Urban Engineering Ecology, and I loved teaching it, and it was a great opportunity to gain teaching experience and interact with students and talk about environmental engineering. And when I do have opportunities, I do try to reach out to people and talk about things like infrastructure awareness, because I think the first step to becoming a more sustainable and resilient society is to become more aware of our infrastructure and how our infrastructure connects us to our environment. So I imagine that a lot of us graduating civil engineers will be impacted by these changes, and we'll have to be prepared to redesign our infrastructure for the future.